Good afternoon, extraordinary guys. We are gonna learn an extraordinary thing in this session right now. You are once again welcome to ODA class where we are learning about liquid pressure. And once we learn about this, we are actually gonna take it from the very start and then understand how exactly this liquid pressure comes in from the pressure in solids. A lot of students that I know of face difficulty in understanding that liquid pressure and solid pressure both are exactly same. But what is the difference? What are the new terms that get introduced? That is what I will tell you. The relation between both of them hopefully will make things a tad bit easier for you. You are with me. My name is Udit Gupta, and let me tell you, not only this, if you are learning here, your learning will be maximized to the fullest of its potential if only you join ODA class. Now, this ODA class is an app where you can learn a lot of good things. And the thing is that if you want to make sure that you unleash the full potential of this app, ODA class, you must join the bridge course. What is the bridge course? If you are looking out to learn, starting every Monday, we are having a course that runs for 1 week. That means it's gonna be there for 7 days. In these 7 days, the first 6 days are meant to learn, and there are three maths and three science classes just to make sure that you have understood some of the very difficult concepts in some of the most easiest ways possible. Not only that, if you are learning those difficult concepts, you might have some problems, you might have some doubts, and for that purpose, we keep a personal teacher just for you. It's called the academic mentor teacher who will be there for this full 1 week to support you, to help you with any doubts that you gather along. Now, you might be thinking that is there anything else that happens in these 6 days? So, if you are learning, you are getting your doubts cleared, you can also get access to homework each and every day. That is for 6 continuous days. After each and every class, you can find some questions just to make sure that you have reiterated all the concepts in your head and you have made sure that they are there 100%. एकदम ठोस बैठ जाए खोपड़ी में. That is going to be the agenda of this bridge course. And we talked about 6 days. What happens on the seventh day? Tada! There's a test that take place on the seventh day to make sure that all of this, are you able to gather it and get it once it is required? Are you able to face that pressure situation? That is why the tests are there on the app as well. Now, once you're done with everything, let's say that this 1 week course is over, far over. Let's say a month back you did this bridge course and you want to see whether you are able to recollect things or not. Here's the PDF books as well. So that means it's a full package where you get everything. And if you're thinking that your parents might not be interested in this course, let me tell you what I haven't written out here. That is, there's the parent teacher meeting as well. So it's something where everybody can come, everybody can enjoy, everybody can learn. And if you want to be a part of this, all you need to do is check out this link in the description below. Click on that to make sure you are enrolling amongst the best courses in India right now. Now, let me tell you one final thing that this bridge course actually is costing 499 rupees for anybody who does not watch this session. But just because you're here, my teacher discount can help you get this in just 49 rupees. Isn't that great? I hope that you will now make sure that you make this payment done. Get yourselves enrolled in the bridge course. It's only 3 days left now, and this would be a great time to come here. But I'll tell you who else is great. I will be teaching you this session. This session is going to be great. This topic is going to be great. My name is Udit Gupta. For all those who don't know me, I've done my mechanical engineering from NIT Allahabad. I teach physics. I have around 9 years of teaching experience, close to 10 now. And I have mentored a lot of students along the way. And that means you could be the next one of them. And you can also make sure that you are learning in the best possible way. let's go ahead. Let's talk about what are the things we are talking about today. Thing number one, topic number one. Why is this pressure there? We can understand that if a solid thing stands on some area, we learnt about it in a previous or last to last session that pressure equals thrust per unit area. But why exactly does it come in liquid? That is what we would like to know. We would talk about this as the first thing where we will try to relate solid pressure to liquid pressure. The next thing would be we would talk about a liquid column. Why exactly are we talking about this thing in particular? Because this is the thing that is going to be asked, and this is the thing that is a thing of consideration everywhere whenever you will talk about liquid pressure. And the third thing, we're going to talk about a device. We're going to talk about an instrument. It's called manometer, and we'll see what function it does. But also, please make sure that you are again following it step by step, one to two to three. If you miss out anywhere, do not forget to just rewind back a little and get to make sure that you have understood one topic 100%. Let's start. We're talking about why this pressure, and first of all, we're considering a beaker that has some water. Now, this beaker or this glass or this tumbler or a container, this is containing, let us say, any liquid. The most common liquid we find is water, so I fill it with water. Now, what I'm going to do is I will very carefully take out water from this, right? So, as soon as I do this, I take out water. A lot of students say, sir, how can you take out water? If it was ice, you can hold and take it out, but how can you take out water? Let's say that I have those water bending capacities. Let's say I am that version of Avatar who can make sure that only the liquid part we are to consider. So we just take out this liquid part. Now, just assume that maybe there was no container and the liquid somehow holding its shape gets out. What can you say about this liquid? I think the first thing that you can say is that this liquid will have some weight. And if I say that the mass of this, if I say the mass of this particular water is m, if g is the acceleration due to gravity, the force that would be exerted due to gravity will be given as mg. Right. So this is just very basic thing that we've taken out water. We're considering its weight, and this weight turns out to be mg. Right. What is the next thing that I want you to do? I want you to understand that there is a term called density, which equals mass per unit volume. Now, if you're thinking that why exactly is this word introduced? Why is this word density introduced over here? The reason is that density is very, very closely related to liquids. And if it is related to liquids, we must use this term, right? Some students call it D, I call it rho. So you can use whichever term that you want. Just make sure that you remember density equals mass per unit volume. That is M divided by V. Okay, if you have understood this part, now I would like to go to the next part where we are actually relating it to pressure. We've started with density. We've understood that this term is of vital importance. Now, what do we do as the next thing? We say that we can write this mg. If you see, we were talking about that this was the weight, right? This was the weight that we had considered, and this weight can now be written as rho vg. How exactly? We said that density equals mass divided by volume, right? So what is the next thing that I can say? I can say that rho equals m divided by v. V being the volume of this mass. And I can say using cross multiplication, I don't know how many of you know that, but I'm pretty sure you would expect that you can multiply these things. So I think I can say m into 1, which is m itself, equals rho into v, that is rho v. We put this thing out there in place of M. So once we have done this, now we are very close to getting a liquid pressure. And now if we use this basic term, this basic definition that pressure is thrust per unit area or force per unit area, you have your force over here. You can call area as A, which I'll do in the next slide. So over here, you can actually get this final pressure in terms of what you want. Let us say over here, this is the area A. This area I am writing down as A. I had already said that V over here is the volume, and let me assume that this height is H. So what exactly am I saying? If I say that pressure equals force per unit area, this force initially I write this down as mg, area I write it out as A itself, mg later on turned out to be rho vg. So mg I'm putting as rho vg. Area I'm putting at as A itself. And now comes the final trick. This is somewhat magic, but you'll have to believe me that this volume can be written. This volume can be written in terms of area A and in terms of height H. How will I write it? I'll simply say volume equals area into height. And once I have put this value of V as AH, this comes in from here. So over here you'll see this A and A cancels out and you get the final pressure as rho GH, or some people will call it DGH. That is density into acceleration due to gravity into height. That is this column. So that is why we were talking about liquid column first thing. Second thing, I have actually gotten this formula, that is the formula for liquid pressure, using the definition of solid pressure, that is pressure equal force per unit area. So I hope you have gathered all of it. If you are facing a problem anywhere, never forget or do not hesitate to go back, rewind again, and make sure that you can also derive this out, because this derivation just might come in as a 5-mark question. Right. So we have understood why this pressure. We have talked about the liquid column as well. So now I would like to move forward, do a quiz so that you'll understand it even better. So here's the question for you. It says there is height of atmosphere given. We are assuming that this is round about 50 kilometers. And the next thing that we are given is that we have the density of air. It is given as 1.2 kg per meter cube. Density is mass, that is kg, per unit volume, that is meter cube. And finally, you are also said that you can take the value of g as 10 meter per second square. You have to tell this pressure exerted by the atmosphere. So what will we say? First of all, let us try to see some options if they are there. Are they? Yes, I think they are just about falling down. Let's see what these options are. We have the first option as 300 kilopascal. We have the second option as 600 kilopascal. We have the third option as 900 and similarly 1200. So this is effectively 300 into 1000 Pascal. Similarly, this option is 600 into 1000 Pascal. And I hope you can write down the rest too as well. All you need to do is you need to multiply with 1000, because the data that were given, it is basically kilopascal and kilo means 1000. So how will you go ahead in this question? Let us try to do so. We know that there is just one formula that we have understood, that pressure equals rho into G into H, or we can call it D into G into H, where D is the density, G is given as 10, H is also given. So what will I do? If I want to get this pressure, I will write down the density is 1.2 kg per meter cube multiplied by g, that is 10 meter per second square, and h, that is given as 50 kilometers. Now the thing is, I can see this meter cube is there, I can see this meter is there, but this thing over here bugs me a lot. Why kilometer? Can I put it in meters? Obviously I can. Let us do that. It would be 1.2 kg per meter cube into 10 meter per second square into 50,000 meters. That is how we convert kilometers to meters. And now if I just multiply these three terms, which three terms? Let me do it in some different thing. Let me do it in black. If I multiply 1.2 and 10 and 50,000, I think I will get my answer. I think if I just remove all the thousand thingy, because this will go as kilo, so I will get 1.2 into 10 into 50 kilo Pascal. I hope that now the answer is pretty much evident. 1.2 into 5 would be somewhere near 6. So I am going to go with option number B. So I think I have mostly gotten it correct. If you want, you can take a screenshot. If you want, you can note things down. But yes, the next place that we see is that 600 kilopascal is absolutely correct answer. Let's go ahead. Let's do another thing. We are talking about the final thing now, and that is this device called manometer. Now, what exactly is a manometer? It looks something like this. This is a YouTube manometer, and similarly, you have another manometer over here. But what is its function? What exactly will it do? It will actually measure the pressure in fluids. Now, please remember one very critical thing, that we are not talking about liquids anymore. If I talk about a fluid, I will say this is both liquid as well as gases. So both the things, it can measure the pressure. It can measure the pressure in a liquid. It can also measure the pressure of a gas. You must have had gas cylinders at your home, those red colored ones. You can measure the pressure using a manometer. House is something we'll talk about later, but you can just remember this is the instrument that you would be looking for whenever you want to calculate the pressure. Let us have another question. It's a very simple question that says pressure can be measured by what in liquids and gases. Again, the options are dropping in. I hope that by now you would have already known that the one that starts with M over here, because we see liquids and gases, we're going to talk about fluids. We said fluids is manometer. So obviously C option over here becomes correct. Right, guys, let's have another question. We have another question that is quite a big one. Let's read what exactly it says. Where should the hole be made in a cylindrical container? We need a cylindrical container. It is filled with water, and we want to make a hole such that we get a stream of water. If you do a hole, water will obviously come out. It might come out with some low velocity, it might come out with greater velocity. We want exactly the maximum velocity. What will you do? Where exactly will you put that hole? The options might help you out over here. It says that if you put it near the top, or if you put near the middle, or if you put near the bottom, or if you do any one of these, which one is actually gonna get you the maximum stream of velocity? I think if I try to draw this out, if I have a cylindrical container and if it is absolutely filled with water, I think that if I'm gonna do a hole over here, it might come out like this. If I do a hole here, it might come out like this. And if I do a hole here, it might just come out like this. So this means that my option that should be correct through my intuition happens to be near the bottom. Right? C option is absolutely correct. There's also a subjective question for you. It is again the same question. If you want the diagram related to it, you can have this one. You can take the screenshot of this. This is near the bottom, as you can see, and it is going out with the maximum velocity. As you can see, this is the strongest jet, while this one at the top happens to be the weakest jet. So this was all that we had to do in this class. If you loved it, do not forget to check out our app where more awesome things are happening. There are more awesome classes taken by the best of teachers. And yes, this course, bridge course, would be the next big thing that you are getting into only if you enroll. It has a lot of things, as you can see. All these things I told you earlier as well. You're gonna have 1 week of fun. You have 6 classes. You have the mentor teacher. You have the tests, the homeworks, and the parent teacher meetings and whatnot. Everything over here. All you need to do is press on the link below. This is the link that is given. Go out, share it with your friends. It's gonna be helpful for them as well. And once you make sure that you have enrolled, you are just gonna start off on Monday with a bang. And another thing that I forgot to mention, that once you come over here, it's not only that you would be getting a lot of knowledge, not only that you would be getting a lot of learning, but at the same time, you can get your hands upon some of these awesome ODA coins, right? You can download the app, you can come into the bridge course and you can win these coins. These coins are effectively gonna help you get your hands on these super awesome goodies. So why don't you go out, check them out on the app, and make sure that if you have loved this class, you like and share it with your friends. Also, do press on that bell icon to subscribe and never miss an update. This is me signing off.